At the end of this video, you will agree with me why I say Ohm's law is incomplete and how voltage divider rule, which is VDR rule, is the fastest way and the smartest way to analyze circuit theory when it comes to voltage drop across a resistive element in a series circuit. Let's dive straight into it. Okay, assuming we are given this problem and we are asked to find the voltage drop across the resistive element in the circuit, what are we going to do? First of all, we know that from Ohm's law that V is equal to what? IR. And for us to find the voltage drop across the individual resistance, we must first of all the voltage that will drop across the resistor R1 according to Ohm's law will be V1, which is equal to what? I R1. And the voltage that will drop across resistor R2 will be V2, which is equal to what? I R2. And the voltage that will drop across resistor R3 will be V3, which is equal to what? I R3. But from this circuit, we are not given current. Current is not given. And from this formula, which is the Ohm's law formula, we need current for us to what? Find the voltage drop across resistor R1 and resistor R2, which is V1, V2, and V3. We need the value of current. So what are we going to do? We will look for the value of current first for us to what? Find the voltage that will drop across the individual resistance. So we will look for the value of current using Ohm's law, which is I will be equal to what? V or what? R. So from this formula, we will look for what? Current. And we know that the value of current, we are given E, so it will be E. So the value of current, which is I, is equal to what? 20, which is the value of the supply voltage, or what? The total resistance, which we don't know. So we must first of all look for the what? Total resistance for us to look for what? Current. So let me clear here. So the total resistance of the network will be what? ROT, which will be what? R1 plus R2 plus what? R3. It will be the sum of the individual resistor in the circuit, which will be ROT will be what? Resistor R1, which is 6 ohms plus 3 ohms plus 1 ohms, which is equal to what? 10 ohms. So 10 ohms is the total resistance in the circuit. So now we can now look for the value of current for Ohm's law, which is I is equal to what? E, which is the supply voltage over what? The total resistance, which we know that the supply voltage from the circuit is 20 volts, and the total current is what? The total resistance, which we just calculated, is what? 10 ohms. So 10, we're going to 20 how many times? That is 2 times, which is what? 2 amps. So the value of our current is what? 2 amps. Then now we can now look for the word voltage drop, since we have gotten the value of what? Current in the network. So the voltage that will drop across the resistor R1 will be what? V1, which will be what? I multiplied by what? R1. So now we will now substitute the value of what? Current into this equation, which will be what? The value of current is 2 multiplied by what? The value of our resistance of what? R1, which is what? 6 ohms. So 2 multiplied by 6 is 12 volts. So it is 12 volts that will drop across the resistor what? R1. So for the resistor R2, which is V2, it will be what? I what? R2, which will be what? 2, which is the current multiplied by 1 resistance, value of resistor R2, which is 3 ohms, which 2 times 3 is 6 volts. So for V3, it will be I multiplied by what? R3. The current is what? From our calculated value is 2 multiplied by what? The resistance value of resistor R3, which is 1 ohms. So the voltage that we drop across resistor R03 will be what? 2 times 1, which is what? 2 volts. So these are the voltage that we drop across what? The individual what? Resistor. So now let us input the value of our voltage to the word circuit. So we have the voltage that drop across resistor R01, which is 12 volts. Is 12 volts, which here is the positive terminal of the resistor, and here is the negative terminal of the resistor. And the voltage that drop across resistor what? R02 is what? 6 volts. And the voltage that drop across resistor R03 is what? 2 volts. Don't be confused. Let me clear here. Okay. So now we have gotten the value of what? Voltage drop. And what is voltage divider rule? Voltage divider rule states that in a series circuit, the voltage across a resistive element will divide as the magnitude of the resistance level. It says that the voltage will drop across a resistive element in a series circuit based on the value of the word resistance. The voltage across a resistive element will divide as the magnitude of the word resistive level. If you can notice from this board, the largest resistor here is resistor R1, which is 6 ohms, and which took almost half of the supply voltage, which is 12 volts. 12 volts drop across resistor R1, which is half of the supply voltage, which means resistor R1 took most of the supply voltage, while the smallest resistor, which is the resistor R03, which is 1 ohms, took the least voltage, which is 2 volts. So therefore, resistor R1, which is the largest resistor in the circuit, resistor R1 is 6 times the resistance level of resistor R1 is 6 times the resistance level of resistor R03. I mean, if I should multiply resistor R03 by 6, it will give us the resistance level of resistor R01, which means the resistance level of resistor R03 is 1 ohms. So if I should multiply 6 by 1, which is the resistance level of resistor R03, which is multiplied by 6, it will give us 6 ohms, which is it will give us the resistance level of resistor R01, which means resistor R03 6 times the value of resistor R03 will give us the resistance value of resistor R01. Since the resistance value of resistor R01 is 6 times the resistance value of resistor R03, the voltage that will drop across resistor R01 will be 6 times the voltage level across resistor R03. I also mean that since it is 2 volts that drop across resistor R03, that the voltage that will drop across resistor R01 will be 6 times the voltage that drop across resistor R03. It will be 6 times the value of voltage that drop across resistor R03. Which means if I should multiply the voltage level of resistor R03 by 6, we will now find the voltage that will drop across resistor R01. Which means the voltage level of resistor R03 is 2 volts, which means if I should multiply 2, which is the voltage level of resistor R03 by 6, we will have 12 volts, which means 6 times the voltage level of resistor R03 will give us the voltage level of R01, the voltage level of resistor R01, and also resistor R02, 2 times resistor R02 is twice the value of resistor R01 is twice the resistance level of resistor R02. The resistance level of resistor R01 is twice the resistance level of resistor R02. I mean 2 times the resistance level of resistor R02 will give us the resistance level of resistor R01. If we should multiply the resistance level of resistor R02 here is 3 ohms. If we should multiply 2 by these 3 ohms, we should multiply by 2, it will give us the resistance level of resistor R01, which is 6 ohms. So therefore, since it is 2 times the value of resistor R2 that will give us resistance level resistor R1. So therefore, the voltage that will drop across resistor R1 is 2 times the voltage level of what resistor what R2, which is the voltage level of resistor R2 is 6 volts. So if we should multiply 2 by the voltage level of resistor what R2, it will give us the voltage level of what resistor what R1, which is multiplied by 2. We have 12 volts. So it is 12 volts, 2 times the value of what the voltage level of resistor R2 will give us the voltage level of resistor what R1, which is 12 volts. Remember that when we look for the voltage that drop across the individual resistive elements, we first of all determine the value of what current before we are able to what find the voltage level. I mean, for us to look for the voltage level of this circuit, current was first. We first of all determine the value of current before we were able to find the voltage level. That is how Ohm's law operates. And that was the reason why voltage divider rule now came into place. Voltage divider rule permits us to determine the voltage level without first finding the value of current in the circuit. That is why voltage divider rule is the smartest way and the fastest way of analyzing circuit series circuits, especially during exam. But Ohm's law, if you use Ohm's law, you must first of all look for the value of current. For example, the voltage that we drop across to R1, it will be V1 equals to what? I R1. But with Ohm's law, we must first of all look for the value of current, which is not given. We must first of all look for the value of current for us to find the voltage that we drop across to what? R1. But with voltage divider rule, there is no need for us to look for the value of current. All we have to do is to substitute the value of the resistive elements into the equation, and we are done. There is no need for you to find current for us to now look for the voltage drop. That is why I say Ohm's law is incomplete. Ohm's law is very it consumes time. Why voltage divider rule is the smartest way, the fastest way to analyze series circuit problem when it comes to voltage drop across a series element. Okay, and how can we be able to derive the voltage divider rule formula? Okay, let us derive the voltage divider rule. Let us derive the voltage divider rule using this above circuit. Let's say we have 2 resistors in series like this, connected to a voltage source, like this. Let's call here E, and let's call here R1, let's call here R2. And the current that will flows in the circuit, let it be I. All we need to do now is to record the properties or behavior of a series circuit. We know that in a series circuit, current is the same. It is this supply current that flows across resistor R1 resistor R2. Current is the same in a series circuit. Don't remember that here will be V1, the voltage that will drop here will be V1, while the voltage that will drop here will be V2. And since current is the same in a series circuit, therefore I, which is the supply current, will be equals to the current that will flows according to R1 with respect to R1 will be I1. Will be equals to the current that will flows according to R2 with respect to V2 will be I2. So we can call this equation 1 since current is the same in a series circuit. Also, we know that the total resistance in a series circuit is given by ROT, which is the total resistance in a series circuit, is equals to the sum of the individual resistance, which is R1 plus what? Arrow 2. We will now call it equation 2. We also know that the voltage in a series circuit differs. The voltage that we drop across to arrow 1 is different from the voltage that we drop across to arrow 2, because voltage drop depends on the value of the word resistance. It depends on the resistance level of the individual word resistor. So therefore, since the voltage is differs, E, which is the supply voltage, will be equals to the sum of the individual voltage drop, which will be V1 plus what? V2. We can call this equation 3. But we know that from Ohm's law, V is equals to what? I arrow. We can call it I arrow T. What are we going to do? Since we know that in a series circuit, current is the same throughout the entire world network, we will make current, which is I, a subject of the formula from Ohm's law. So therefore, I will be equals to what? Since the source voltage is E, let here be what? E. Will be what? E. The current will be E over what? Arrow T. But from Ohm's law, we know that the total resistance is arrow 1 plus what? Arrow 2. So we substitute the total resistance into this equation. We will have that I, which is the current, will be E divided by what? Arrow 1 plus what? Arrow 2. We can call this equation 4. Okay, let me clean here. Let me clean here. Let me clean here. Okay, since we are getting the value of our current now, we can now find the voltage that will drop across the individual resistor, which is the voltage that will drop across resistor arrow 1 will be what? V1, which will be what? I arrow 1. All we need to do now is to substitute the value of I into this equation. So we will have that V1 will now be equals to what? E, which will be what? Supply voltage over what? Arrow 1 plus arrow 2 multiplied by what? Arrow 1. We just substitute the value of I, which is E over arrow 1 plus arrow 2 into this word equation. So now this equation is the same thing as V1, which is equals to what? Since we are dealing with arrow 1, since we are dealing with the voltage of across to what? V1, it will be what? Arrow 1 is the same thing as arrow 1 all over arrow 1 plus what? Arrow 2 multiplied by what? This E. So now here is the what? Is the formula that we will use to what? Find the voltage that will drop across is to what? V arrow 1, which is what? V1. So the voltage that will drop across resistor what? V2, which is arrow 2, will be what? V2 from Ohm's law, which will be equals to I arrow 2. We will substitute this value of what? Current into this equation also. We will have that V2 will be equals to what? E over what? Arrow 1 plus what? Arrow 2 multiplied by what? This arrow 2, which is the same thing as V2 will be equals to arrow 2 with respect to V2, since we are dealing with the second voltage law, all over arrow 1 plus what? Arrow 2 multiplied by what? E. So this is the second equation. This is the second formula that we will use to find the voltage that will drop across what? Arrow 2, which is V2. So now let us use this formula to find what? The voltage drop across what? This circuit. Let us delete all these other words. Answer that we got from Ohm's law. Now we will now use voltage divider rule to find our what? Voltage drop in this circuit. The other example we did was we used Ohm's law to find the voltage drop. Now we will now use voltage divider rule, which we will not find the value of current again. there will be no need for us to find current, but with Ohm's law, we will look for current for us to find the voltage that will drop across the world, the resistive element. But with voltage divider rule, we will not look for the value of current again. So the voltage that will drop across to other one, with respect to voltage divider rule, will be what V1, which is from the formula we just derived, will be R1 or over the sum of the total resistance of the circuit, which will be the sum of resistor R1, resistor R2, and resistor R3, which will be R1 plus R2 and plus R3 multiplied by E. That is this formula. But the difference is just that one resistor is added from this question. That is just the difference, but it's the same thing. So now the voltage now, which is V1 now, will be equals to other one is 6 ohms divided by 6 plus 3 plus 1, which is resistor R1 plus resistor R2 plus resistor R3, which is 6 plus 3 plus 1 multiplied by the source voltage, which is 20. So now V1, let me clean here. So now V1 will be equal to what? 6 times 2 is 12. So 6 times 20 will be 120 divided by what? 6 plus 3 plus 1 is 10. So 0 will take away this 0. So the voltage I will drop across to other one, which is V1, will be what? 12 volts. Are you seeing that it is the same with the value of voltage drop when we use Ohm's law to calculate? It's the same thing. But the difference is just that with voltage divider rule, there is no need for you to find current again, which saves time and energy. It saves time. But with Ohm's law, you will go back and find the current again before you will be able to find the voltage that will now drop across the resistor, which is time consuming. So now the voltage that will drop across the R2 will be V2 with this formula, which will be R2 with the formula over R1 plus R2 plus R3 multiplied by E. So V2 will now be equal to what? 3, which is the resistance value of resistor R2 over 6 plus 3 plus 1 multiplied by the source voltage, which is 20, which V2 will be equal to 3 times 2 is 6. So 3 times 2 is 6. So 3 times 20 is 60 over 6 plus 3 plus 1 is 10. So this we take away this, so it will be equal to 6 volts. And also the voltage that will drop across resistor R3 will be V3, which will be R3 over R1 plus R2 plus R3 multiplied by E. So V3 will be 1 ohms divided by if I should put 6 plus 3 plus 1 is 10 multiplied by 20, which is the source voltage. So 1 times 20 V3 is equal to 20 divided by 10, which will be equal to this. We take away this is 2 volts. So the voltage is the same, and this is the easiest way to find voltage drop across a resistive element in a series circuit. So drop in the comment section which method is the simplest. Is it Ohm's law or voltage divider rule? Because to me, voltage divider rule is the simplest method. It saves time and it is very helpful if you apply it in exam, during exam period. It saves time and what? But Ohm's law is time consuming. It will consume your time. It's first for you to find the current before you can be able to find the voltage that will now drop across the individual resistor. So drop in the comment section which method is the fastest for you.